Okay, I'm having a look at the 2024 Maths Methods External Assessment paper. So I'm looking at paper 2, the Tech Active paper, and just starting off with the multiple choice questions. So the first question we have here is the probability of hitting a target in a particular binomial experiment is 0.72. Determine the mean of the number of hits if the experiment is repeated 8 times. So there are our key pieces of information there, the 8 times and the 0.72. Now we know that our mean is equal to NP, so that's going to be 8 times 0.72, and this is Tech Active, so we can grab our calculator, and we get 5.76. So looking over there to the answers, that is C. In question 2, we have the expected value of a continuous random variable x with the probability density function listed here. Now we want to, if we're doing a finding expected value, we're going to put an extra x into that function there. So instead of being x squared, I'm going to make that x cubed. So I'm going to put that in there, the 0.25x to the power of 3. Then I'll graph that, and I'm looking between 0 and the cube root of 12. So I can do my second trace, 7. My lower limit is 0, and my upper limit is the cube root of 12. And so that gives me 1.717. So looking over to the answers, that would be 1.72, which is A. For question 3, we have the derivative of a function f of x is given by f dash x is sine 2x, and it's known that f of pi on 2 is equal to 4, and we're wanting to determine f of x. So we need to integrate that. So if we're integrating, we know we are putting out the front, the instead of 2x, it's going to be 1 on 2. We also know that sine goes to negative cos when we integrate, so I'm going to pop a negative there. The 2x stays the same, and we have a plus c on the end. So that's where we're going to use this information here. But having this base part means we can already rule out A and B as the answers, and we're just finding out if it's going to be C or D and looking at the 3.5 or the 4.5. So then we're going to use this information here to solve for C. So we have 4 is equal to negative a half cos 2x plus c, and our x there is pi on 2. So then we can, and my calculator is in radians, so I can use my pi button there. So I've got 2 times pi on 2 is going to give me the 3.14. Then I'm going to do cos of that, and I get negative 1. I've got to times that by negative 0.5, and I get 0.5. So I'm going to have 0.5 plus c is equal to 4. So that means my c must be 3.5 to give me the 4 as the answer, which means my answer there is C. For question 4, I've got a Bernoulli distribution where the outcomes for rolling a 6-sided die are 4 and not 4. And it says determine the variance of the resulting Bernoulli distribution in this scenario. So we don't have a number of trials, which means we're just going with our n equals 1. So our variance is n p outside of p, 1 take p. So we've got 1 times 1/6 times 5/6, and that's going to give us, when we do that, uh, 5 on 36, which gives us 0.1388, which is B as our answer. Then we've got our question 5, the mass of adult kookaburras in a certain region is normally distributed with a mean of 300 and a standard deviation of 13. So drawing my little picture straight away, I've got the 300 in the middle there. It then gives us a few statements here, and we want to try and do this as quickly as possible rather than checking each one of these. So it's got 287. Now that would be 1 standard deviation below and 1 above. Now we know that that is definitely not 34%, because that's 1 standard deviation above and below is going to give us the 95%, which means then, sorry, not 95%, if we do the, I'll show you how you can check it. So if we put in our 287 and our 313, it's the 64%. Or 68%, sorry, when we do it that way, 68%. So it's given us half of that rather than the double. So we know that this part is the 68%. So then when it tells us 68% is 274 to 326, we know it can't be that either because we already know that the 68% is 287 to 313. Then 95% are we between 261 and 326. So 261 to 326, we can double check that if you're unsure. Doing that again here, oops, wrong one. Our normal CDF, we will put in our 261 and 326, and our mean is 300, and our standard deviation is 13, and we get 97.5. So it's actually given us the upper percent, okay, it's given 97.5, they're saying 95, so that's out. So then this is our last one. So checking this one, and a sneaky way of we're doing that is just bring that down and just change these numbers here. So we've got 261 and 339, and checking that one, and we get the 99.7. So we've got that there. So trying to rule out as many as we can as we go, as quickly as possible, is the way to go in the multi-choice. Question 6, we have determined the derivative of 2x cos 3x. So here we've got our product rule. So we can already rule out these two, like they're not going to work because we're not going to have, that's only got one term there. So here we've got our uv, u is equal to 2x, u dash is equal to 2, v is equal to cos 3x, so v dash is equal to negative 3 sine 3x. So looking at that, we wouldn't get two positive answers, so we could automatically rule that out and know that we're going to get that part A as our answer there, because we've got u dash v, 2 and cos 3x there, that's that part, and then the 2x and the minus 3 sine 3x, when we multiply that we would get the minus 6 sine 3x there. So trying to rule out as many as you can, as quick as you can. Question 7 I feel is a little bit of a trick question. If you recognise what they're asking for, it can make it quite quick there. So we've got our 40 degrees here. So we are identifying the possible angles, possible values for A in the triangle. So when we do our sign rule, we know we can always look at the ambiguous case, which is where we can have two answers, and those two answers always add to 180. So what we can do is look down that line and cross out any that don't add to 180 because we know they're not going to be the two options for an ambiguous case. So 13.5 and 86.5 obviously gone, 53.5, 86.5 gone, 13.5 and 126.5 gone, which leaves us with the 53.5, and double checking that, and we get 180. So you could have gone through and solved for one of the angles there, but knowing that we're looking for that ambiguous case scenario and knowing that they have to add to 180 means we can jump to that answer really quickly. Question 8, calculating the total enclosed area between the graph x squared minus x minus 6 between 1 and 5. Now the total enclosed area is a big key, that it's not just going to be straight from 1 to 5. So looking at that graph, so we've got x squared, take x, take 6, we can see that some of it is below the line, some is above. So if we just shaded in between 1 and 5, you would see how some is below and some is above. We want this changeover part. It's fairly obvious that that's at 3. So if we just do second trace 7 between 1 and 3, we get negative 7.33. So we just want the positive version of that. Then we're going to go between 3 and 5. And we get 12.66. When we add them together, we are going to get 20. So the answer is D there. Then we are on to question 9, where we have a graph given to us. And so we are told a couple of things about there. We know that f dash x equals 0. So we're looking for a stationary point. So we've got these three here. This could be an inflection point, so it could be included, but it also tells us that f double dash x is less than 0. So that means it's not going to be an inflection point. We're now down to these 3 that it could be. The one that's less than 0 means that is going to be a maximum. So obviously that's out because it's a minimum, that's out because it's a minimum, and we are left with R. Question 10. We've got the velocity of an object is given by this. The change in displacement of the object from 4 to 5 seconds is going to be what? So we can just do that one again on our calculator by putting in that equation. So we've got 0.4x squared plus 3x. We graph that. Looking at between 4 and 5, it's all positive, so we can just go second trace 7 between 4 and 5. And we get 21.633, which is B. And they are our multi-choice questions. In my next videos, I'm going to go through each of the short response ones separately.